Hello, welcome. Let's try to solve another Leetcode problem. 2271. Maximum white tiles covered by a carpet. So for this problem, we are giving a 2D integer array tiles. So inside of the tiles, we're going to have a left and a right. So represent that every tile j in the range from Li to Ri is colored white. So in the drawing, we can see that that's going to be the first tile. So it's going to be from index 1 to index 5. Or from number 1 to number 5. And for the next tile, it's going to be 10, 11. So the next tile is going to be 12 and 18. And the next tile is going to be 20, 25. And 30, 32. So we are also giving the length of the carpet. And we can put the carpet anywhere. What are we going to do? We just want to cover the tiles as many as possible. So we're going to return the maximum number of white tiles that can be covered by the carpet. So how can we solve this problem? So for example, this is going to be some tiles, and it's going to be like this. And this is our carpet. So can we put the carpet here to cover more tiles, or can we put it here? Maybe for this tile it is bigger. Maybe we put here, we covered all the tiles. But here there's some empty spaces. It means this places we didn't cover. So this means we want to find the greedy idea to use to check how many tiles we can cover. If we want to cover the maximum tiles, we always want to put the carpet aligned to the left side or aligned to the right side. So for example, if we align the left side, it is here, or maybe that one is going to be here, or maybe this one going to be here, or the last one going to be here. It is the maximum. Or we can align to the right side because it is exactly the same. So if we align to the right side, so this is our carpet. We covered some tiles, and for here we also covered some tiles, and there's some empty spaces, and also for this position and the last position. So this means if we align to the left or align to the right, definitely we can cover the maximum tiles. Now the problem becomes what kind of algorithm we should use? Basically we need to check. So for example, if let me make the tiles bigger. So if the tiles is bigger, it's like that. So definitely if we are sliding the carpet, there are going to be some tiles it's going to be covered, and some tiles which will not be covered. So currently this tiles is covered. So what if I move to the next position? So for example, my next position is here. So this means some areas, this kind of tiles which will not be covered, and we also increased some covered tiles, which is going to be this one. And definitely in between there's some empty spaces. But it can also happen like that. So for example, if the carpet is here, so this means this tiles is disappeared. Definitely this is the left, this is the right side. This means this tiles is totally disappeared. And from here we covered all these tiles. So how can we calculate it easily? We're going to use two variables to calculate it. So the first variable we're going to call it cover. So this means how many tiles we can cover, and another variable we're going to call it uncover. So this means while we are sliding the carpet, there are going to be some tiles which will be uncovered. So for example, if we slide the tiles from this position to this position, and this tile will be uncovered. So this means we're going to minus the uncovered we're gonna use the covered tiles minus the uncovered tiles. Yeah, so if we slide from here, yeah, maybe we can use the first example. This is 1, this is 5. So currently our carpet length is 10. Yeah. So if we align to the first position to the right side, so definitely the result is going to be 5 because this area is going to be covered. Yeah. Now what if we move to the next position? Maybe this is a 10 and 11. This is not a good drawing, but for analyzing the problem, let's just analyze like that. So if this is a 10 and 11, and definitely this is going to be the carpet. So the carpet next position going to be aligned to 11. Yeah, and here going to be this number 2. Yeah, so it's going to be from 2 to 11. So this is the carpet. Yeah. So currently, how many tiles we covered? So from 10 to 11 there are 2, and here from 2 to 5 there are 4. So in total there are going to be 6 tiles which we're going to cover. So 6 is more than 5. This means this is going to be the up to here this is going to be the maximum tiles. It's going to be 6. But how can we calculate it? Yeah, so from the beginning, so this is a from the beginning this is a 5, but while we slide the carpet to the next one, so it's going to be aligned to this 11. So this means it's going to increase 2. Why? Because this is a 10 and 11. We're going to increase this those 2 tiles because those 2 will be covered. So 5 plus 2 is going to be 7. So this is the covered tiles. But there are going to be other tiles which is going to be uncovered. So what is uncovered tiles? It is this 2 minus this 1. Yeah, because before this areas 1 to 2, this areas this 1 is also covered. But currently it moved to 2. This means this 1 is not covered. So this means we're going to minus 1. So finally the answer is going to be 6. Yeah. So this is one of the situations. So what happens to the next case? So let me just clean it a little bit, and let's just move to the next. What's going to happen for the next? Yeah. So for the next one, it's going to be 12 and 18. So maybe here it's going to be 12, and this one going to be 18. So if we slide to the next, so definitely here going to be the right side, and for the left side it's going to be 11. Let me check. Yeah, not 11. It's going to be 9, right? Because 18 minus 9 plus 1 it is 10. So it's going to be 9. It's going to be here. Yeah. So this is going to be the carpet. If we slide to the next position, aligned to the right side of the tiles, yeah. So this one going to be 9, and this one going to be 18. Yeah. So the length of the carpet is 10. 18 minus 9 plus 1 it's going to be 10. So what happens to here? So if we slide to the next position, first of all, we're going to increase the new tiles, which is going to be 12 to 18. So 18 minus 12 plus 1, so it's going to be 7. So this means 6 gonna plus a 7. Yeah. So this is the new tiles we're going to cover because we're going to cover more tiles. Yeah. And what happens for here? My calculation is not okay. Let me just recalculate it. Because currently this is my result, it is 6. Yeah. But for the cover, it is 2 plus 5, it is 7. Yeah. So this is the cover variable, it is 7. Now I'm going to increase the cover. It's going to be 12 to 18. It means 18 minus 12 plus 1. It means 7 plus 7, which is going to be 14. So this is going to be the covered. So which is going to be uncovered? So if we slide from here, so this means this position. So I'm going to call it the capital left position. So we're going to have the capital left or capital right. So this is going to be the capital left position. So this position is going to be more than the tiles position. So this means the current tile position is going to be the tiles right. So 9 is more than 5. Yeah. So this basically means we're gonna reduce the covered positions. So this means 7 plus 7, we're gonna minus a 5. Yeah. So it's gonna be 9. Yeah. 14 minus 5 is gonna be 9. Yeah. And finally we're gonna return this 9. So currently if we align it here, if we put the tiles here, basically it's gonna be the maximum. Yeah. If we put the tiles here, it's gonna be the maximum. Or if we put the tiles here, if we align it to the left, it's also okay. If we align it to the right, it's also okay. It's the same result. Yeah. Now we're gonna try to write a sliding window to solve the problem. Yeah. So we're gonna use some variables. So I'm gonna call it result and cover. So this means how many tiles currently it is covered, and I'm gonna prepare a current position it is left. So this means this left tiles from the left side. This left is the whole tiles. If it is inside of the sliding window, I'm gonna check it. If it goes out of the sliding window, here the sliding window is just the carpet, the left and the right of the cap. Here the this left is just the left side position. If I put a tile anywhere aligned to the right, this left is the current left tile positions. Yeah, current tile positions at the left. And so from the beginning, I'm gonna set all those variables to be 0, and then I'm gonna sort the tiles. So after that, I'm gonna check each one of the tiles. So I'm gonna use the TRTL inside the tiles. I'm gonna prepare. I'm gonna update the cover first. Yeah. Because for the carpet, it will always align to the right. Yeah. So for each of the carpet, it will always align to the right. So for this tiles, I'm gonna align to the right. So for this cover, I'm gonna plus equal to the tr minus tl plus 1. And I also want to prepare another variable. I'm gonna call it carpet left. Yeah, this is going to be easier just for the calculation or easier for the understanding of the problem. So carpet left is, it means if I put any carpet aligned to the right, where is my left position? So I'm going to use this one, use this variable to represent the carpet left position. Yeah. So what's going to be the carpet left position? Because it is aligned at the TR, it means the tile right, it's going to be minus the carpet length plus 1. So this is going to be the carpet left position. Now for the sliding window, we need to check if maybe if this tiles goes out of my current window. Yeah. So my current window is controlled by the length of the tiles, definitely. So if it goes out of the window, what's going to happen is what is the current position? So it's going to be the tiles left with 1, right side. If it is less than the carpet left position, it means yeah. So if this position, this is the right current position, it goes out of the window. So definitely we want to reduce it. Yeah, we want to update the left, and we're gonna reduce the cover. So this is exactly the sliding window. So cover gonna minus tiles with the left 1 minus tiles with left 0 plus 1. So this is going to be the cover. So we're going to reduce the cover. Yeah, because it goes out of the window, definitely we want to reduce. So this means because we go to the next one, maybe we go to this one and go to this one. Yeah. And we go to this one, the red colored one. It goes out of the window. What are we going to do? Yeah, we just need to reduce the cover. So cover going to minus the length of the current tiles, and the left pointer gonna plus equal to 1, because we're gonna check the next one. So if it still meets the conditions, we're gonna still reduce it. Yeah. So for example, this one, maybe there is another one. Yeah. Maybe there's another one. We're gonna still reduce it. Yeah. Now we're gonna use another variable. It's gonna be uncover. So the uncovered means it is still So the uncover means this is still this is the tiles, and this is still the carpet. Maybe this is another tile. We're gonna align to the right side. It is here, aligned to the right side. Yeah. But there are gonna be some uncovered tiles. So for example, this is gonna be uncovered, these areas. But we need to calculate what gonna be how much gonna be the uncovered. Yeah. So we're gonna use the carpet left minus the left positions, which is gonna be the uncovered. So it's going to be the maximum. So we're going to control it to be at least 0. Yeah. So it's going to be the maximum of carpet left minus the current tiles with left. Let me think about it. Let me check the drawing. So yeah. So this is going to be the carpet left. It's going to be minus the current tiles left with 0, because 0 is at the left side. Basically, we wanted to check these areas. Yeah. So it's going to be 0. But what happens is something like that. So maybe this tiles is bigger. It is like this. So this is maybe the tiles is bigger. The carpet is bigger. So this is the carpet. Yeah, definitely. Here is another tiles maybe. Yeah. So this is the carpet. Yeah. Maybe this is bigger. So this means we don't need to reduce any uncover, so we're gonna check a maximum to be 0. If it is a negative value, definitely we're gonna set it to be 0. So we're gonna choose the maximum with this one and 0. Yeah. Now we can update the final result. So it's gonna be the maximum of the result with the cover minus the uncovered ones. Yeah, covered tiles with the uncovered tiles. So finally we're gonna return the result. Let me check. I did something wrong, definitely. I didn't get the final result. So it is a 0, so this is a 1, definitely. Yeah, it's not like that. Let me check it. So this is my cover. And let me just print out the cover and uncover to check what is wrong with it. Yeah, I did some negative values. This is definitely not right. It's gonna be, yeah, I did something wrong. It's gonna be TL and TR. I did it TR and TL. Definitely it is wrong. It should be the tile left and the tile right. Yeah. Now as you can see, it works. And we can also check some values. So this is the cover from the beginning, 5 and 0, and 7 and 1. This is 9, gonna be the maximum. And this is 13 minus 4, it's gonna be the maximum. Yeah. Now let me just submit it to check if it works. Yeah, as you can see, it works. Yeah. Now we're gonna use this problem to solve another problem. So it's gonna be, yeah, it's gonna be Leetcode 3413, maximum coils from k consecutive bags. How can we use the same code to solve another problem? So let me just copy the same code and copy it from here. Yeah. So this is our code. Because those two problems are similar, so that means we can solve it using the same code. Yeah, so this is exactly 2271, and this is another 13413, maximum coil from k consecutive bags. Yeah, so the description is nearly similar. The only difference is for this problem we're gonna have a weight. Yeah. Let me just make some drawing to explain the difference. Yeah. So maybe we're gonna have something like 1, 2. Here we're gonna have something like 4 to 5. Yeah. But for this problem we have some weight. Maybe here we have a weight of 1, and here we have a weight of 2. Yeah. So this means for the alignment, we are not going to check the right alignment for the carpet, and here is for this case. Yeah, but for our problem we're going to use the carpet. We are not only going to check the right alignment, but we are also check the left alignment. So this is the right alignment. Maybe we also want to check the left. Definitely, we also want to check the left alignment. Yeah, because it's gonna have a different weight. Maybe this weight is 2, this weight is 1. Maybe this is better. Maybe this 1, this 2. Maybe the right alignment is better. So this means we're gonna check 2 of the alignment. Yeah. So now let's just define a function. We're gonna call it max cover. And inside we're gonna use tiles and carpet length. Yeah. So this is the function, and we used it exactly from the problem, Leetcode problem 2271. Yeah. Now we're gonna use it. So this is a method. Basically, we can directly call the function. So let's just try to call the function to check that if it works. Yeah. We're gonna call max cover, and inside here it's gonna be the coils, and another value gonna be k. Yeah. And let's just do a little bit of things, because here we have another variable which is gonna be the weight. So here we're gonna use a c as cost. Yeah. So the cover gonna be this one, and time and cost. It's gonna times this is c, because c gonna be the cost. Yeah. Capital left is gonna be the same. Yeah. Here it's also gonna be the same, but here the calculation gonna be different, right? So this one gonna times the weight. It's gonna be the tiles from the left, and tiles of the left with index 2, because this one gonna be the cost. And here we also need to use the cost. So let's just times the cost. So it's gonna be the capital left minus the tiles left 0, and we also need to times the tiles left 2. It's gonna be the cost. Yeah. Now let me just run it to check if it works. Yeah. As you can see, it works, but definitely it cannot pass for all testing cases, because this is the alignment of the left. Because we want to have the alignment from the left or from the right. Yeah, both ways. Alignment from the right or alignment from the left. Yeah, we need 2 alignments, but currently we only have 1 alignment. Yeah. So if I submit it, definitely it didn't work. Yeah, but even before that, I need, let me put this testing case inside. But even before that, I need to sort the coils first. Yeah. So the coils, we're gonna sort it first. Yeah. So now let me just run it. Yeah, but it didn't work for this testing case, because we didn't align for the left side. Yeah. So let me just use an example to explain. So currently for our alignment, for example, we have 1, 2, 4, 5. So this is our alignment, and this is alignment to the right, and this is also alignment to the right, and this is the carpet, and this may be, yeah, the carpet or the K, the capital length. Yeah. So this is 1, 2, this is 4, 5. It is okay. Yeah. But what happens? Maybe the weight, this is 1, this is 2. It doesn't matter. Yeah. So how can we align to the right? So this means we're gonna turn the values of 1 and 2 to -2 and -1. This value we're gonna turn it to -4 and -5. So after that, if we turn the values, it's gonna be something like this. This is gonna be -5. This is gonna be -4, and here we're gonna turn 2 to -2, and this is -1. Yeah. Now we're gonna still align to the right. So what happens is, currently, if we turn the values, if we reverse, first of all, if we reverse the coils array, and then we just turn the AB to BA. Now what happens? If we reverse the values, and then we're gonna assign it to the negative values. So what happens is that it is exactly like the alignment of the right. Yeah. We're gonna still use the alignment of the right, but it is actually the alignment of the left. As you can see, this is 4 to 5. This is alignment to the left. So 4 to 5, alignment to the left. Yeah. 1 to 2, it is also alignment to the left. So 4 to 5, 1 to 2, alignment to the left. Yeah. So this is exactly what we are doing. If we do such kind of a reverse, and we also turn the numbers to negative values, so this is actually, yeah, the alignment to the left. So we're gonna set these values to result, and now we're gonna check all the coils. So for first of all, let's just reverse it, and then for C inside the coils, C0, C1 gonna equal to minus C1 and minus C0. So after that, we're gonna directly use it. Yeah, maximum of result with the function. So it's gonna be the maximum cover, which gonna be coils and k. Yeah. So now let's just run it and submit it to check if it works. Now as you can see, it works and it's pretty fast, and the time complexity is n log n. Thank you for watching. See you next time.